In this video I'm going to show you how to use an 8-digit LED display. For this tutorial you'll need an Arduino, 5 jumper wires which are male to female, and you need your 8-digit LED display which is based on the MAX7219 chipset. Our PCB consists of 8 positions with 8 LED segments. So we have 7 to display the number and 1 to display the decimal. This means that we have 64 LEDs on our PCB. We don't want to wire all these LEDs separately. Therefore, there is on the back of your PCB a chip which is the MAX7219. This chip is called a shift register. I'm going to briefly explain how this works. A shift register has 8 memory positions in this example. Each position corresponds with a segment of our digit. So the ones means they're on and the zeros means they're off. So what happens is that we have 3 different pins. Data in, clock, data out. So when I set data in to a 1 and I give the clock a pulse, then the shift register shifts to the right and stores that digit. So as shown over here, this was the state of the shift register. Then I've set 0 on the data in and gave 1 clock pulse. Now all these digits are moved to the right one position, so the last one falls out of the shift register and our 0 is stored over here. In this way we can have 1 data wire, and if we give 8 clock pulses we are able to set every LED for 1 digit. But if you need more positions, you can use the data out. In the example below, the clock is connected, and when the data out has the digit which falls out, like here, it is stored in the first position of the second shift register. Well, I'm not exactly sure how the MAX7219, how many positions of storage it has. It might be that it has 64 positions, so there is no need to wire shift registers together. But the nice thing is that if you have 2 of our LED PCBs, you can connect the data out of one to the data in of the next PCB, so you can connect even more digits. Connecting the wires is pretty straightforward. First we have the yellow wire which goes to the 5V on the Arduino. We have the ground, which is the green wire, which is connected over here next to the 5V. Then we have 3 data wires, which is data in, chip select and the clock. The blue wire, which is the data in, is connected to pin 7 or the Arduino. The second data line is the chip select, the red wire, which is connected to 5. The grey wire, the clock signal, is connected to pin 6.
So this is the first example I've created for our LED display. And as you can see on line 21, we're using the LED control library. So we're going to install that first. So we go to Sketch, Include Library, Manage Libraries. And then we're searching for LED control. And as you can see here, you have the LED control library by Eberhard Fahle. And it's working with the MAX7219 and MAX7221, and that's the one we need. So you can install this library. So after you've installed the LED control library, let's have a look at the other code. So here on line 28, we initialize the LED control in the variable LC. And for your reference, I've added some comment about which number means what. So the first number is the DIN, second the clock, the fifth the load, and we have 1 display. And if you daisy chain multiple of these LED displays, then you can increase this number so the LED control library knows how many displays you're connecting. For this example, we're only using the setup because we only execute everything once, so the loop is, as you can see here on line 62, is empty. So first on line 34, we wake up the MAX chip, and that we're doing this, actually it's quite funny, we do it by the shutdown command. But since we're making it false, it means you're not shutting it down, so you're waking it up. And in all these commands you see here, the first parameter is the 0, and that's the device ID. Since we're only having one device, it's always 0. So we initialize the display, or we wake it up. Then we set the intensity of the display. So here we set it to 5, and you can use a number between 0 and 15. Keep this in mind when you're using a battery, because setting this to 15 is very bright but drains your battery. Then we clear the display on device 0 with the clear display command. And then we're going to show an 8, the number 8, without a decimal dot. So this last parameter you see here of the setDigit function indicates if it has a decimal dot or not. So on device 0, on position 0, we want to see the digit 8 without a decimal dot. Then the next one is we set on position 2, so we skip one position, we set the number 5 with a decimal dot. So here on line 49 we're setting a character on position 4, and we're using the character A. Keep in mind that we're using single quotes here and not double quotes. Double quotes is for string, single for a character. We set it, the last parameter, to false because we don't want to have a decimal dot. But the thing is with this display, with a segment display, that it cannot show every character you want. For example, if you want to use the N, the problem is that you need diagonal LED segments, and we don't have that. So you cannot make every letter you want to. Then on line 59, that's quite a raw function. It is called setRow, and what you basically do is turn on the segments of a certain position on and off the way you want. So for device 0 on position 6, we use the binary, that's where this B is here, and we use the binary numbers 0, 1, 0, 0, 1, 0, 0, 1. And what this means is that if you look at the 8-segment display schematic, so here we have north, south, and then northwest, mid, northeast, southwest, southeast, and the decimal dot. So here in this command line you see that the first position is the decimal, so that's set to 0. Second, the north, is set to 1, so this one will on. And then the other two positions, so northeast and southeast, will be off. Then the south will be on, and then you see the southwest and northwest will be off, and the mid will be on. So the north, the middle, and the south will be on. So I'm now going to upload this to my Arduino, and I'm going to show you what this looks like.
I've uploaded my sketch to my Arduino. And as we can see, the first position is an 8. We've defined this in our code with setDigit, and the decimal point is off, so it's working. On the next one we have a 5 with our decimal dot, and this one is set with setDigit on the second index, so the third LED, which is also working. On the fourth index, so the fifth LED, we are displaying an A, which we've activated with setChar. So this one is working as well. The last character is our north, middle and south LEDs, which we've created with our setRow. I'm now going to show you how you can create your own symbols. I've created a schema which is in Dutch, but we can translate it as north, middle, south, northwest, northeast, southeast, southwest. And what we're going to do is in 8 binary digits, we can define which LEDs are on or off. So how does this work? In this example, the decimal and the northeast are on. The decimal, the north and the northeast are on. The southeast is off, which is this position. The south and the southwest are on. The northwest is off and the middle is on. So in this way, with these digits as binary defined, you can show a 2. In the Arduino code, this is defined as the capital B followed by 8 digits. This is the way you can define a binary number. If you use set row on index of the device 0 and the index of the LED position 6, which is the last digit, you can display this binary code. In this example, the south, southwest, northwest and middle are turned on and the others are off. So if you look over here, you see the northwest, the southwest, the south and the middle is turned on, which is the lowercase t. So in this way you can display any kind of LEDs you want, or you can turn them on and off, you can make animations, you can do whatever you want, since you have full control of each segment of our LED display.
In this second example, I have 3 different functions to print a number. So we're starting with the first one, that's this print number. And what this function does is it takes a number as an integer and translates this to the correct digits on our display. So the highest number we can print is 9,999, since we have 4 positions. So what we need to do is we need to split the number given to this function into the ones, the tens, the hundreds and the thousands. Now, what we can use for this is the modulo operator. The modulo operator is discussed in one of my Arduino programming theory videos, but I briefly summarize it. So if you have a number and you divide it by 10, like here, so if we take 100, it will be 10, but if you divide 90 by 10, it will be 9, etc. But if we have 55 divided by 10, then we get 5.5. Well, what we do here is we take only the complete division, so we're not working with floating points. And this modulo operator does exactly the opposite. So if we have 55 and we do the number, so 55 modulo 10, the answer is 5. Since you can 5 times divide 55 by 10, so then you have 5 remaining, and that's what this function does, while this function here is the number of divisions. So maybe 55 is not the best example. If you take 75 and you do 75 divided by 10, so there fits 7 times 10 fits in that number, but we have a remainder of 5, which is here in the ones stored. So we're going to do this for the ones, for the tens, the hundreds and the thousands. So we first start to determine how many ones there are. So if we have a certain number, we check if there is still a number left. If we have, for example, 6, then the modulo by 10 is 6, but if we divide 6 by 10, 10 doesn't fix into this 6, so we're done. And the whole function continues till we have the thousands, and then what we basically do is set each position. So the third position is the thousands without the decimal dots, then the hundreds, then the tens, and then the ones. So this will show a number on our display. Now if we skip print number 2 and print number 3, we go to the loop, then we first clear the display with a device ID 0, and we use print number in this case, and we print the number I, and I is a variable which I've defined on top here on line 30. We start with 0, and then what we do is increase the number and wait for 100 millis. So what we expect to see is a counter which counts to 9,999. So I'm going to upload this code and show you what it looks like.
I've uploaded the sketch with the first print number function, and as you can see, it's correctly printing the thousands, the hundreds, the tens and the ones. Here is a leading zero, since there are no thousands yet, because we are counting at 200.
So we're now going to look at the second example of the print number. So I'm changing this to print number 2. And then if we look a little bit back to the print number function, we see a lot of duplication. Here you see ones, but it is number modulo 10, here is number modulo 10, here again. And the same goes with number. Here on line 61 it's the same, 66 is the same, and we can only use 4 positions. So it's not very efficient. So if we look at my print number 2, which is a lot shorter, we're going to create an array with bytes, and that's for the 8 positions of our display. So here you see 0, 0, 0, 0, 0, 8 zeros, and that indicates the number for each position on the display. So what we're going to do is we have this number here in this function, and what we're going to do is we're going to split up the number over all these 8 positions. So imagine we have 100, then this will be 1 and it will be 0, 0. If you have 7,500, then this will be the 7, this will be the 5, and this will be 0, 0. So that's what we do in this loop. So basically it's set for each position the correct digit. Then on line 89 we iterate again, and what we do is that we loop over all LED positions. So then we set the digit of device number 0 on position I, so we iterate over each position, which are 8 positions, and then on that position we set the number which we load from the array, here, this array, digits, on position I, and we turn off the decimal. So if you go back to the set digit over here, we set the thousands, the hundreds, the tens and the ones separately. But now we just iterate over this array and set each position the correct number. Well, the advantage of this, that is a lot more clear. You first calculate the number and then you show it. Of course you can combine these two, but for this tutorial I split them up so it's a lot clearer to you what exactly happens. Here we calculate, here we set the LEDs. The LED segments. So I'm going to upload this sketch to my Arduino because the code here with the print number is always the same except of this 2. And then you see how this works and that we can use 8 positions.
This is the running example of print number 2. In print number 2, we've created a function which iterates over each LED. So here we see 5 leading zeros activated, but now we are able to count even further than 9,999.
So I've changed this into print number 3 for the third example. So this one starts at line 97. So here we basically see a lot the same as in our last example, but what I want to do is getting rid of all these zeros. These are so-called leading zeros. I just want to show if I have the number 100, I want to see 100, and all these leading zeros, I want to get rid of them. So what we do here, we create a variable called the first non-zero found, and what we do is we're going backwards through this array and see when the first non-zero number occurs. So here I iterate backwards and then I check if the number is not equal to 0, then we found the first non-zero, and then we start to print the digit on the, or turn the digit on our LED display. So if we have a number, say 100, then the first 5 positions will be ignored because it's not equal to 0, they're equal to 0. So this one will remain false, here, and the non-zero found here remains false as well, so nothing happens. When it finds this first zero here on this position, then the first non-zero is found, so it's set to true, and if so, then it starts printing all the digits. So it's very simple, but very effective, because now we are not showing the leading zeros. I'm going to upload this to my Arduino and show you what it looks like.
In print number 3, we see all the leading zeros are gone. As I showed you in the code, we are looking for the first digit, which is non-zero. So this position is 0, the next one is 0, 0, 0, 0, and then it finds a 2. So when it finds a non-zero digit, it shows the correct number, as shown over here. So now we've removed the leading zeros and we see just a counter, which is able to count over all 8 LEDs.
In this last example, we're going to focus on characters. So what you see here on line 21 is something changed. Here we include the BOT LED control and not the LED control as we did before. Well, there's a reason for this. The LED control library is quite old and doesn't support a lot of characters. I believe A to F, and that's basically it. So what I did is, since it's open source, I've copied the code of LED control and extended it. And if I here look at the top, you see 2 other tabs. So if I open botledcontrol.h, and this is the file also in the course material, you'll see here that I added a lot of other characters. Some characters we can't display, so for example here the M, we cannot display it, so I make it binary zeroed out so you don't see anything. But for others I've tried my best to show as much characters as possible on an 8-segment display. So we include my BOT LED control, so we have the maximum number of characters. So this is the same, we initialize it on the pins as you already know. We have here an index variable set to 0. I'll show you that in a minute where it's used for. Here is the character string. So these are all the characters we're able to display on our segment display. We have a character buffer of 60 positions, and these are exactly 60 different characters. So we initialize our screen, our display, and here on line 47 we convert the char string. So it's this complete string we have. Remember here double quote, so it's a string. And we convert it to our character buffer and we have 60 positions. So now we've converted this string into an array. The nice thing is, with an array we can iterate over this array. So what we do is we set on a character on device 0 on position I and a modulo 8, and then we set the character of the char buff on position I with no decimal point. Well, this could look a little bit odd, and if you think it's quite complex, don't worry about it. You'll see it when you run the program what happens here. What I want to do is fill up 8 positions and then start on the beginning with a new character. So what I do is every time we make one step through this array, I check if the divider is, I check the position which we divide by 8. So if we are at position number 10, for example, then, index number 10, then 10 modulo 8 is 2, because the remainder is 2. So what happens is that we display the 10th index of this array on the second position of the display. So what will happen is it uses position 1, 2, 3, 4, 5, 6, 7, 8 and then continue with 1, because there is no position 9 and you want to show all characters. Here we use the index to pick the correct character, and if we iterate it over all 60 characters, we reset the index to 0. We wait 250 milliseconds and then we go to the next position. So if this all is too complicated, don't worry about it, you'll see it in a minute. And if you have any questions, feel free to add a comment to this video so I can answer your questions. I'm going to upload this to the Arduino and I show you what it looks like.
I've uploaded the code, and as you can see, the Arduino is iterating over all positions in the string and displaying all characters. This concludes this video, and I hope to see you next time.